Hi there, I'm Harry, and today I'll do a comparison of about a few low noise block amplifiers or satellite receivers. I purchased a few of them, a few different models, and I was interested to measure, how good are they. I do have the instrument to do a noise figure measurements, which would tell me if an LNB is how good it is. All of these LNBs you buy nowadays, it says on the box that they are 0.1 noise, the noise figure, which is probably not true. Probably around 1 dB, 0.5 dB, something like that. So I could take them apart, and because the instrument needs to have a hookup into to this. This has a waveguide. I'm not able to interface with that. So if I hook this up and to my instrument to do a noise figure measurement, I have to take it apart. I didn't want to do that. I mean, I will use my LNB to receive the Oscar 100 satellite. So I thought I could just receive that satellite on my parabolic reflector on my dish, and then measure the signal to noise ratio on the beacon. And if I use the same reflector for several of these, I would get a comparison. I could compare these results. So I thought, let's just plug them in, measure the signal to noise ratio with my spectrum analyzer, take that down and see if there's any difference. It's a small reflector, it's about 50 centimeter. So I have around 20 dB of signal to noise ratio on the beacon. So that's what I did today. So let's just dive into that. Okay, here are the LNBs that I will be measuring today. I have two of each, so we could see if there's some variance on them. So, 3 different models. This one from Golden Media, I think I paid 2.7 euros, less than 3 euros for that one. This one was a bit more expensive, 6 euros for that. And this goobay model was also 3 euro, I think. So pretty inexpensive stuff. I know I've tested a lot of these and we built them before. I know this is a 25 megahertz PLL version, and this as well. I think I've opened 1 or 2 and rebuilt these as well. These are also running on a crystal 25 megahertz on a PLL. I don't know about this. We'll see. I hope it's. I haven't opened one of these. I hope that's a 25 mega PLL version as well. What I will do is I'll run them, just as they comes out of the box unmodified, and then I'll probably modify them and for 25 megahertz insertion so that they are a bit more stable. But first I'll measure their sensitivity just as they are out of the box, and so I'll be labeling them and measuring them on my spectrum analyzer. Maybe I'll also measure them on the SDR on the computer. So I know this is pretty decent. I've compared these two before. And in that case, these were a bit more sensitive than the Octagons, but we'll see now. So let's go outside and connect up the first one and get some measurements on this. Okay, here's the antenna that I will be using. It's about 55 centimeters in diameter, so 50 centimeters parabolic mirror. So it's not the biggest one, which is in this application might actually be good. If you had a very large mirror, all of these LNBs would have very good performance, so it might be a good thing. It could actually be too big. So here are the LNBs that I'm gonna test out. Label them up. So let's start and let's remove this one, and we'll get started. We'll take turns, put them here, go inside, measure them, go out again, switch to another one, and until we have measured all 6 of them. Okay, let's see if we can have that without losing this screw. So I'll start with this one. Yeah, being a cameraman, at the same time like doing this takes a while. I know from experience that this should be like in this direction to get the most signal from there. So this is set up for Oscar 100 right now. It's pointing to Oscar 100, and so we should have a good signal. And regardless, I mean, they all will have the same reflector, and they will be pointing in the same direction. So okay, let's I'll continue doing this off camera, and we'll go inside once I've tightened this up. Okay, we're inside. Here's the cable that goes to the LNB on the outside, and here's the power inserter, and so this will get 12 volt from this power supply, and the IF signal will come out of here, go into a couple of preamplifiers just to rise up the level a bit to be above the noise floor of the spectrum analyzer. So here is the measurement, and this is with the power off, and now I turn on the power. So you see there's a good, it's 20 dB at least. Noise floor from the LNB is at least 20 dB above this spectrum analyzer. This is not set up for 10 dB per division. This is set up for 5 dB per division at the moment, just to, you know, get a bit more visible signals. So let's find the beacon. They should be in here. We're looking at 739 megahertz, so the beacon signal should be in here somewhere. There was the signal. Let's see if that could actually, that was it. So I'll increase the span a bit. So there you go. So that's the one that we're interested in. It looks like it's a very strong signal. It's not. I mean, you have to remember that's only 5 dB per division right now. So the trick down to measuring this, you could look at, I mean, this is the marker. You could look at this value here, but what I'm interested in is signal to noise ratio. So what I will do is I will use a feature called display line. The display line is something you can set yourself. So it's this purple line there that I can move. So what I can do is I can measure from the peak down to this display line. So you see it's already set up like that. So if the marker and display line is at the same level, it shows 0 dB. So what I can do is I can set that myself where I believe the noise floor is set at. And then we'll get the signal strength from the beacon up here. Right now 22 decibel over the noise. I'll also do a bit of averaging. It's already set up to not measure peaks, but to measure average into the detector. But I'll also do 20 scans and averaging them together just to bring the noise level down. And as this is a continuous signal, you will get a nice average value here. I've noticed that the signal level from the Oscar 100 actually do vary a lot. Up to 5 dB of variation can be seen. So I think this is a good method. I'm doing 10 sweeps here, and then we'll take that measurement values and note it down. And this would be the measurement value for the first LNB. Okay, I need to adjust the display line a bit. I think I got it at a good level. So this LNB right now is receiving the beacon with 22 decibels over the noise floor. So that's the value we'll give this first one. This first one was a golden. So I'll write that down. Okay, I've done a second measurement here on this golden media LNB, 21.8 this time, and I'll restart it and do another calculations here. So I mean, there will be some variance even if we try to get it down. Probably half a dB, maybe up to a decibel of variance. We'll see. I don't think we can get it any better than that. But at least we'll try to minimize it as much as possible. And I think by using this method of averaging, we'll get pretty decent results, I think. I think I adjusted that one correctly as well. So the first one we had 22 dB, then 21.7, and now 21.1, so 21.6 maybe. I'll take down 21.6 signal to noise ratio on the first one. And let's go outside and switch it out to the second one. Okay, so this was the first golden media that we measured, and let's put in number 2. We measure that, and then do the rest, and we'll see what the difference is. Maybe it is not that much. We'll see. It's going to be interesting. Okay, let's see what kind of results we can get from this one. Seems to be a lot of stations now on the satellites. That's I mean, it's Sunday afternoon, so that would make sense. So this has to be the CV beacon. There's a signal to the left. It shouldn't be there, but I guess someone isn't caring too much. Oh, okay. So that has to be the CV beacon, SSB stations, that's the digital one. So I'll put that in the center like this, and okay, I'll start averaging on the second one here. So we'll do 10 averaging and check that value, and I'll do that 3 times and sort of find a mean value of these 3 measurements. Okay, so this one ended up at 20.8. So that would mean probably 21 decibel is the mean of the three measurements. First one was 20.7, then 21.5, then 20.8. So I'll take that down as 21.0. Okay, let's go outside again and we'll complete this. This is the table as we stand now. The first one, the second LNB, and I'll do these and complete this table and see what the signal to noise ratio on the other one are as well. Okay, the first of the Octagon LNBs inserted. Let's see how this fares compared to the other one. Alright, so this is the first one of the Octagon LNBs. And I'll start the averaging here. You can see the noise floor is less on this one, which is not much. I mean, you have to remember it's just 5 decibel per division, so it's slightly less amplification in this LNB, I would say. Alright, let's start the averaging and we'll see how this one fares. Okay, first measurement, 17.7 dB, and there we go, third value, 17.3 I would say. Yeah, so these are not as good as the golden media ones. That's my experiences before as well. So I'll just put, so first value 17.7, second 16.3, and then 17.3. So I mean it would be around, that's a dB and that's a half a dB. So 17.0 would be I think an average of these. Alright, let's try out number 2. Okay, the second one of the Octagon came in at 17.7, so you can see it's a bit worse than the golden media. And now it's time to go out and test the goobay, I think it was the name, and see how they do. Okay, the last model, the goobay product. So we'll see how this do. I'm not sure exactly what focal distance to use here. Could be off, but I don't think it's much then. I'll try to keep the angle the same for everyone, slightly off in this angle, so should be a good fair comparison. Alright, this is the last model I'm testing, the goobay model. Looks to be pretty okay. Okay, I just measured the first of the goobay, came in at 19.5. So one more to measure, and then we can look at the results for all 3 of them. Okay, last measurements are in, so let's summarize this. Okay, so I measured all of the LNBs and the results are in. These were the ones I measured. So about 2.7 euro, less than 3 euros for this one, if I remember correctly. Octagon is 6 euro. This one was also around 3 euro. So the results for these are the following. The golden media, this one, was the best one. It gave a signal to noise radio from the Oscar 100 satellite. So this is in Sweden, South Sweden. My reflector was a 50 centimeter parabolic reflector, and with this fitted, I got a signal to noise ratio on the digital beacon of about 21.3 decibel. So that's the best one. The second best one was this goobay. It gave about 1 dB less, 20.2 decibel. And the Octagon OSLG Green HQ was the worst. It gave a signal to noise ratio of 17.4 decibel. So there you are. These three should be okay if you have a big, larger reflector than I, but as they are also more expensive, I wouldn't go with these. This one, perfectly okay. This one as well. And I'll probably do a separate video where I take these apart and modify them to send 25 megahertz up to these so that they don't drift anymore. They do drift when they have the crystal inside. I'll have done that modification. I'll see if I do a video on that one. Even if I don't do, there you go. That's the result for these 3 LNBs. So thank you for watching, and see you in the next one.